And welcome everybody to the Daily Space Weather Show. We've got some spectacular solar imagery, as you may have come to expect. And we've got some amazing Earth weather as well. Some shocking rains coming to portions of the southeastern U.S. We'll get to it. This is yesterday plus today from SDO. 304 angstroms. There is a new sunspot that just rose along the eastern limb. Let's zoom in a little bit closer on that. That is August 27th and August 28th to date. So really low levels of activity here. Just a small increase in the sunspot number coming with that new group. That would be this area right over here. Right in there. A new sunspot has indeed risen. We don't always show 335 angstroms, but we're going to show it today because we're using the SDO browse data feature once again. And here's the full disk view, complete with timestamps. By the way, there has also been a little bit of growth in this large sunspot just moving into the western longitudes. But for the most part, pretty stable as far as sunspot activity. Here's colorized magnetogram. These videos are all from August 27th and August 28th, up until the point where we produced this show. Quick side note. Press the like button. If you haven't pressed the like button, please do so. Don't worry, we'll wait. Have you pressed the like button yet? Thanks. It does a thing at a place where dudes view the stuff here on YouTube. Thanks for pressing that like button. Check it out, some imagery of Sangay here. As Sangay erupts, let's see what else is on the list. Mount Mayan is producing some sort of volcanic ash cloud. We're not sure how large it is. Popocatépetl is producing constant emissions. No ash plume size listed there. Fuego, frequent emissions. No ash plume size listed there. Nevado del Ruiz in Colombia, exploding flight level 190. That's a 19,000-foot ash plume. And Sangay down there in Ecuador has been producing something like a 20 to 23,000-foot plume of volcanic ash, like a flight level 230. Volcanic ash not observed from Revenador in that same nation. Sabancaya, however, in Peru, continues to explode. It's producing a 23,000-foot ash plume. And Ubinas, a 21,000-foot ash plume. Please don't pole vault the caldera. Seismic activity is next. We are seeing a 7-magnitude earthquake drought. We also did see a little earthquake swarm in Indonesia that we'll briefly take a look at. It's been an extended period since we saw a 7-magnitude quake. So just a brief look here at Indonesia. Several quakes happening there. Remember, any earthquake could be a foreshock, so I figured I would mention it. Anyway, we'll call out quakes of a 5 or greater magnitude. And we had a drought of those as well, up until yesterday around 1703, when a 5.0 hit Japan. Then at 2144, there was a 5.7 at Colombia. That one looks like it did a bunch of damage. And that was at 2144 Universal Time. That is the largest quake of the past 24, I believe. Looks like only 3 5 or greater magnitude quakes have happened. Also a 5.0 at Peru. That one was at 4:14 Universal Time this morning. Small earthquake swarm in the around Puerto Rico there as well. And let's get back to space. Here is SDO in 171 angstroms. We do also see some plasma instability up here in the northeastern limb. So that is another place to watch. Really, the eastern limb has been where the action has been happening. There was a huge CME that came from there as well that we'll also cover NASA's model of here in just a moment. First, let's look at the 10.7 centimeter radio flux, which is now at 142 solar flux units. Here's the 1 year graph to put it in context. The radio flux is the black line. The red line is the sunspot number. Those are proportional data sets. Sunspot number and radio flux move up and down together throughout the solar cycle. So it looks like NOAA is forecasting a coronal hole high-speed stream here. No arguments from me there. NOAA expecting an increase in the solar wind density here, a dip in the solar wind density tomorrow, and then an increase in the solar wind speed. So that's a coronal hole high-speed stream there on NOAA's forecast. However, not expecting it to produce any major space weather events. So it'll only cause a modest uptick in the global geomagnetism. Only expecting a KP 2.67 there. So expect the possibility of an increase in the solar wind density coming today. As far as NASA's forecast, NASA does model the coronal mass ejection that we covered in yesterday's video, missing Earth to the east. So there you can see it popping off, and that is indeed a massive CME. Again, NASA not expecting it to hit Earth as depicted here in the inner planet's Enlil spiral. And it is showing the coronal hole high-speed stream there as well as quite mild. So no very well-defined coronal holes likely to be sending material Earth's way. Next, we'll look at Earth's geomagnetic moment from space. Here's magnetohydrodynamic pressure modeled by the Space Weather Modeling Framework for the past 4 hours. No major changes happening there. Next, the last 4 hours of Earth's magnetic moment from the ground. Again, it is geomagnetically calm conditions here. We've got a mild solar wind environment here. We'll let that play through as it's refreshed. We don't edit these videos to get them onto your screen in as timely a fashion as we can. As with any videos about weather, whether it's space or Earth, we don't want them to expire. That's the last 4 hours of Earth's magnetic moment from the ground. KP index currently at 2. KP2 is the current situation for the planetary K index, an average of global geomagnetism, and here is the solar wind data. And one of the things I'd illustrate here is that this is a great example of how different spacecraft are going to show different solar wind regimes, right? So here we've got this low density solar wind as measured by that is the Discover. And you've got a higher density solar wind here measured by the ACE. So that's just a great example of how at Lagrange 1 you can have completely different plasma environments there. So that's a switching of the instrument used. The ACE and Discover there are seeing different densities and different solar wind speeds as well. So a variation there of about 60 kilometers per second, 405 as measured by the, again, that's the Discover. .400 by the Discover and about 340 by the ACE, shown by that green bar down there. Current conditions are, let's see, that is ACE and Discover, currently showing about just under 6 protons per cubic centimeter, 5.78 for the solar wind density. Solar wind speed here very slow, 325 kilometers per second. The GOES magnetometers here showing some variations around midnight local time for the GOES 18. A rapid swing there as the GOES 18 is on the opposite side of the it's on the dark side of the planet. That's midnight local time for the GOES 18. Those are geosynchronous near equatorial satellites. Next, the top view ecliptic plane field plot, and you're going to see the North Pole current sheet here depicted in green getting a little bit longer. That is associated with that new sunspot that just rose in the eastern limb. So there could be a little bit of a delay there in the arrival of the South Pole current sheet. Right now, Earth kind of right in the middle of a North Pole current sheet. Next line of sight field plot. And let's move to coronal holes. So here's the coronal hole situation for the past 4 days. And the coronal hole anticipated to show a density spike today in the solar wind data is of North Pole orientation. Let's take a look at those from SDO. So there is August 27th and August 28th to date in 211 angstroms. And those are all North Pole oriented coronal holes there. And let's move on to sunspots. So the likelihood of large solar flares isn't really all that high. We have had a little bit of growth in the leading portion of sunspot 3413. Besides that, we're seeing mostly stability. Here's a view of yesterday plus today from SDO, the SDO continuum. And while we're on sunspots, we'll also show 1700 angstroms. Next, SEPs, solar energetic particles, as measured by the GOES 16 proton flux. Nothing doing. It's flatlined. As far as the X-ray flux goes, well, it's kind of low here. So, current background X-ray flux is around a B6.27. And we've barely even seen a C-class intensification. We haven't seen a C-class intensification since yesterday first thing in the morning. So, quite quiet here as far as solar flares. There is some likelihood of flares on the eastern limb. I'd say that's the most likely place to see a large solar flare. Both in this area up here, and this new sunspot does look like it has some magnetic complexity. So those would be the two places that we could see some flaring. That's SDO 94 angstroms. We'll also show SDO 131 angstroms. Another one of the many species of ionized iron there. 131 angstroms is the hottest. The hottest of all the AIA wavelengths. Here's a star chart of what's going on overhead Lehigh Valley, Pennsylvania, where we're located. Smash Staff and I. Venus has become a morning celestial body. If you're up before dawn, go catch that, the third brightest object. And if you're looking higher in the sky near your zenith, Jupiter is up there, while Saturn sets in the west. That's skyandtelescope.org, by the way. And here's your solar system forecast. This is where things are today. We'll advance this 1 week as we approach the August blue moon. That's where things will be on September 9th. And let's talk about the astronomy picture of the day by Craig Stocks Arts. This is a great nebular formation here, located about 10,000 light years from Earth. And this one certainly features some interesting activity, some star formation possibly happening there, some block globules, which you can see in great silhouette. This imagery is depicting oxygen and hydrogen. The hydrogen is the red, the oxygen is the blue. Great view of that. It's known as NGC 281 from the new general catalog. apod.nasa.gov if you want to check it out on your own. And a great dusty filamentary feature there in the middle as well. Next, looking at coronal mass ejections. Here's what went on yesterday. So there's a interesting one coming out of the eastern limb, not earthly directed. That's 100 frames from yesterday. Here come some frames from today. Another 16 frames there. Some outflow there coming out of the northeast as well. So there is some plasma stability happening up there. Did I say plasma instability? Plasma instability. And let's briefly look at SOHO LASCO C2 and C3. We're going to show more details of that. First, we're going to show stereo A. So we do have another coronagraph known as stereo A, which is depicted by that red circle there near the green Earth circle. And there's a view from stereo A. Difference imagery on the right. Raw coronagraph on the left. It does show time and date stamps. And here is SOHO LASCO C2 and C3. And we're really seeing a shortage here, basically. I mean, a shortage of solar flares, sunspots, and CMEs. So very low levels of solar activity here. Don't expect that to persist. We've still got like a year until solar maximum. So there are some coronagraphs for you, and let's move to filaments. So before we look at Lermonth, let's take a look at the SDO 193 angstroms wavelength. It is fairly good at showing filaments. And again, you can see that instability happening up there in the northeastern limb. The source of those outflows that we showed earlier on the coronagraph. And now let's go back to Lermonth. Here's Lermonth, Australia's ground-based hydrogen alpha imagery. And look at the number of filaments. Some of those have names. If you want to find out what they're named, you got to follow us on Twitter. Just follow the hashtag #NameThatFilament. And you too can name filaments after your friends, your foes, or even yourself. Some really massive filaments there, especially on the eastern portion. So, I mean, check out this area up here. Filaments. Filaments. Filaments at the poles. Filaments adjacent to coronal holes. We'll show the grayscale imagery as well to show prominences, which is simply when a filament is hanging off the edge of the visible disk. And you can see quite a few of them. Again, follow us on Twitter if you want to name filaments after living humans. And here are the past couple of hours from the GOES 16 SUVI. And you can see a bit of a crown prominence up there at the northern polar region. Large filament hanging out down here around the southern polar region with a smaller prominence. And let's blast through our bonus features, as there is some interesting weather about to strike for sure. And some accurate forecasts also. So first, satellite charging hazards. Just some minor surface charging there over Mexico and the Eastern Pacific, where low-energy electrons are building up on the outside of spacecraft. Again, those are minor surface charging hazards, not likely to cause major communications breakdowns for those satellites. Here's the GOES electron flux, measured using radiography by the GOES 16 and GOES 18 from their geosynchronous orbits. They measure it at the F flare of the ionosphere, which will also show the vibrational frequency of. Kind of low levels of electron flux here. If we do see the coronal hole high-speed stream impact, you can expect to see this get lower. There's the one-year chart to put the electron flux in context for you. We're already at low to moderate levels. And it looks like NOAA agrees, expecting a further downtick in those relativistic electrons. Again, they're measured at the F layer of the ionosphere. Feel free to pause the video on this frame if you're new to the channel and not familiar with atmospheric temperatures, the penetration of electromagnetic radiation, or atmospheric chemical densities. Here is the vibrational frequency of that layer, the F layer. We are seeing some minor anomalies in this, and you can expect those to increase over the next month as we approach the September equinox. The equinoxes are the time when we see the most geomagnetic unrest and so on because of the Russell-McLaren effect, which is caused by an acceleration of electrons in the outer Van Allen belt. It basically has to do with the angle of attack for the incoming solar wind. Here's the anomalogram, anomaly in megahertz from a 30-day median for the ionosphere, and quite a lot of low-frequency anomalies here popping up. So lots of red there showing up. Those are the low-frequency anomalies. High-frequency anomalies shown in blue. Let's show the latest image. There's 10 o'clock universal time for the ionogram and 10 o'clock universal time for the anomalogram. We also show total electron content. Feel free to pause the video on this frame if you're not familiar with these distances in miles. So here's our total electron content forecast. Those will be the most likely places for GPS errors. Try using Wi-Fi location accuracy if you're expecting navigational errors. That could help if there are Wi-Fi hotspots around your navigational process. Pretty normal there. And here's the anomaly from the 10-day average for the total electron content over North America. No major anomalies happening there either. We'll close out the space weather section of this video and blast through meteorology after we show the latest intensitygram and the latest colorized magnetogram. So first, this new sunspot. There it is. And it is, so far, it's only alpha class. I only see one polarity umbra. It is of south pole orientation. And it looks like another sunspot may be rising up here. Is it? Nope, looks like just an active region. Another active region up to its north there. Those are plages, not sunspots. This sunspot looks like it's actually degraded a bit now. So it was showing some signs of growth of those leading umbrae, and now it looks like it's breaking down. So there's that sunspot. Those umbrae in the leading portion of that not looking so strong anymore. It's still beta gamma class, but it's actually less likely to produce a large flare. That one down there, that one is also beta gamma class. Beta gamma class. So not only a reduction in flaring, a reduction in the likelihood of large flares, except on the eastern limb. So this is now the most likely place to see a large flare, and that is pretty unlikely as well. Let's move to meteorology. Because again, some interesting stuff happening here, especially around Florida and Georgia really are in the crosshairs. So, and some accurate forecasts here. The GFS model agreeing with what I said yesterday about the jet stream for this system. So what we're looking at here is mean sea level pressure. You can see this strong low here forming off of the east coast of the Yucatan Peninsula. It is going to move like this right across Florida Panhandle and Georgia, dropping massive quantities of rain. Tropical storm and hurricane forecasts are along the west coast of Florida. So that is the situation. We'll show you more here in a moment. First, let's show global weather patterns. Here are the surface winds of the east. There still is a typhoon there off the coast of the Philippines. Here are the jet streams to this side of the planet. Jet streams of the central world. Surface winds of the central world. Strong winds over the central Mediterranean there. And here are the surface winds of the west, the Americas. And here are the jet streams. So again, we're going to show a pressure forecast here. We're going to show the GFS and Euro model. And this is not looking good for places like Tallahassee and southern Georgia also. So this is the GFS model. We're going to advance this. There's 1 day. There's Wednesday. And sometime around the morning on Wednesday, expecting landfall from this. This is the pressure, by the way. And that is going to be significant indeed. Expecting storm surges along the east coast, the west coast of Florida as well. So that's the GFS model. The Euro model here has it making landfall a little bit earlier and a little bit farther to the east. So that's the situation. And we'll show some more forecasts on that. First, the current state of clouds and fog. And by the way, that Atlantic hurricane has intensified as well. It now has an eye wall again. So the eye wall formed, disintegrated, and then reformed. And you can see that there. Out in the West Atlantic. And there's a closer view of that. Next to your weather.gov map, and you're going to see hurricane and tropical storm warnings there along the Florida coast. Get your weather alerts yourself at weather.gov, the homepage of the National Weather Service. And let's show some forecasts. Here is the GFS total accumulated precipitation forecast. And that is showing some areas there with like 10 inches of rain. Yeah. 9 to 10 inches of rain forecast there for portions of Florida and Georgia. So be prepared for that as flat areas drain slowly. 72-hour GFS total accumulated precipitation forecast in inches. Here's a GFS pressure and precipitation forecast over the same period, 72 hours. And man, oh man, the pressure is going to stay quite low there. It's barely even going to drop as it moves over land. So usually those low pressure cells weaken significantly and break up as they move over land. This one looks like it's going to stay rather intact over the next 3 days. Also, this hurricane up here is indeed going to be pushed to the east as we forecasted yesterday because of the jet stream. So the jet stream will help out there, moving that farther out to sea. And it'll help surfers on the east coast as well because you'll get some sweet waves. And last but not least, here is the GFS jet stream forecast. You see that jet stream curling up there and then pushing that system out to the east rather abruptly there. It will also stay somewhat intact, only dropping down to 965 millibars there according to the GFS model. So that's what's up. Let's take a look at lightning next. And there are some severe storms here around Nolens. Let's take a look at that on our lightningmaps.org site. See where the active strikes are at the moment. Some quite severe weather there south of Gulfport, southeast of Nolens. Also Baton Rouge seeing some cells. But that's a severe thunderstorm there. That could be accompanied by damaging wind and hail and things like water spouts. There's the full map view. By the way, today's featured product is the Croissant Earth Society. So, yeah, Croissant Earth. Stop believing NASA's lies, folks. Pardon the sarcasm. Earth, it's shaped like the French breakfast pastry, not an oblate spheroid. What are you, crazy? You've never heard of Operation Paperclip? By the way, nobody denies the existence of Operation Paperclip. It doesn't mean NASA is trying to prove that the Earth is an oblate spheroid. Most people, educated people, have believed that the Earth was spherical back 2,000 plus years. So this is not any sort of a valid debate about the shape of the planet. Anyway, yes, join the Croissant Earth Society and tell your friends and foes to stop believing NASA's lies. Pardon the sarcasm. You can also support the channel, in addition to merch, via the Hemp Lucid shop. We strive to keep these videos existent, publicly visible, and free for all to view. So before we vanish, help us out by visiting our links. There are more ways as well, like pressing the like button. Have you pressed the like button yet? So lots of products available there on the Hemp Lucid store. How about the Focus Mushroom Gummies? They might improve your performance. You will not feel jittery from it. I don't suspect you will. Maybe you will. I don't know. Try it out yourself. You are a living laboratory. Do some testing. Links below the video as well as on the homepage at smashomash.com. Today's featured product is being worn by me. Actually, at the Amazon shop in our Spaceware collection. It's the King Kamea Hawaiian shirt. I've been collecting Hawaiian shirts for over 20 years. This is possibly my favorite one ever. You can find more Spaceware there as well, like eclipse glasses and more stuff like that. If you want to support the channel via subscription services, consider becoming a member of the Smash team. You'll get additional content. You'll get to read about my crap theory for the solar cycles, the mechanism that underlies the solar cycles. If you join at the gold level, you can even get an @smashomash.com email address. At smashomash.com/smashteam. If you join at the gold level, there's also a silver level and a bronze level. We also send out email alerts to tell people that these videos are coming up. So maybe sign up for those, especially if you are not getting notifications on your feed that the videos are coming up. All these links are available at the homepage at smashomash.com. We launched it back in February of 2019. And welcome to the Neo Renaissance. It's an exciting time for space weather, astrophysics, cosmology, and more. So here are those extreme storms. It's the U.S. Doppler radar map. And these have actually calmed down a little bit since we did show prep. Those are still severe thunderstorms. Mobile getting hit with a very concentrated cell there as well, just to its east especially. Anyway, here's the full 50 states view. Precipitation looks like it's waning at Alaska. We're going to focus on the lower 48 view. Here is clouds and fog over the lower 48. And there is our water vapor map. Here's your recap. And some good news for the Gulf is that there is some dry air there. It's not going to do very much, unfortunately. Massive rains coming to Florida and Georgia especially. Anyway, it's time to close this thing out. Thanks for tuning into the Smash News Network, least busted name in news. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.